So we're going to go over, so this is, I guess I'll call it a liquids training, but it will skew a little bit into like solids and how solids are produced and kind of what ends up over in solids handling. The last time we discussed, we had a meeting, we talked about SRT and how do we pick our SRT. Today we're going to take like almost a little bit of a step back and discuss what our SRT means when we talk about yield and our overall plant mass balance. So we're going to talk about typical activated sludge components, how is sludge produced, how do we waste, what is SRT, and then what drives our SRT selection. We are going to have problems today, and I am going to wait and have you work the problems out. So I recommend that at least one person on this call will have a pen and paper, otherwise we're going to be here for a while. So our typical activated sludge components, I think this is pretty standard for everybody, but we have our raw influent or primary effluent, depending on what plant you're at. And basically, this is, for this call today, this is going to be what is kind of in our influent, our substrate, or our food for our microbes. This is going to be one of our inputs to our mass balance. So when you think about a mass balance in a system, if I were to draw a box around this whole thing, a mass balance is typically, when you're looking at it, it's what's coming into the system and what's going out of the system, and how do you account for that? So this is our kind of our area, our inputs, our influent, our effluent, and then we have our waste activated sludge. So those are the only things coming into and out of our systems. And so when we think about a mass balance on that, that's where we can start to really start looking at, well, what's coming in, and then we can really start to predict potentially what's coming out of the system. And so that's what we're really going to focus on the first half of today's training is just understanding this mass balance here. So let's get into how is sludge produced. So when we start looking at sludge productions and kind of basics, I'm going to flip over to this. So we have food comes in. So it's like our BOD, right? Our bugs eat BOD. So that'll be what we're going to focus mostly today on BOD. Our bugs then consume it, or they basically eat it, just like we eat a meal to sustain ourselves. They're eating the BOD not because we ask them to. They're eating the BOD because it's how they support themselves in life. It's how they keep maintaining themselves, and it's also how they reproduce. So that's where the bugs will reproduce once they consume it. And then once they reproduce, we remove them or waste them out basically in equilibrium. So we want to keep a certain amount of them in the system, but we also want to waste them out as we produce them so we don't have too much. That's kind of where you get this circle over here on the left, is where we really have our biomass response, where maybe we have an increase in BOD coming in, our mixed liquor maybe goes up, we adjust our wasting, and then we get to our SRT target, to which another condition change happens. Maybe it's a peak weather event, maybe it's decreased loading, increased loading. Maybe we brought a basin online. Maybe we took a basin offline. And our biomass is all going to respond to that. And so this is just kind of the intro to what we're looking at when we talk about our systems, and what's actually going on in that system. So how do bugs grow and reproduce? So again, we have our substrate, which is our BOD in this case. So we're talking about our BOD coming into the system. If it was nitrifiers, we would be talking about ammonium. And so otherwise, but the reason we focus so much on BOD is because BOD is largely responsible for most of the mass in our system. So when we look at the amount of bugs we have in our system, most of them are coming from BOD, influent BOD, and BOD and reproduction. And so that's where we really focus on how much BOD is coming into a system versus how much mixed liquor we have. Our nitrifiers are a very, very small fraction of our total mixed liquor. So the substrate or food is basically taken in by bacteria to be broken down. And basically what they're doing is they're taking complex BOD and they're breaking it down into like sugars. So within the cell, they're breaking it down into sugars so that they can easily use it for energy production. That energy is then taken by the cell and used for different things. One of the things is just maintenance. So just like you and I, we need daily maintenance. We need daily energy to maintain ourselves and our bodies and keep doing what we're doing. And then if there's excess food, that's where you start to see synthesis. And synthesis is really where we have new cells. So when we say synthesis, that we're basically giving birth to new cells, and we're reproducing and doubling the original bacteria. And to have this synthesis or new cells, we need to have excess food. So if there's not excess food in the system, um, you won't have reproduction. They're basically gonna maintain. They're gonna use energy for maintenance first, and then excess energy goes to new cells. Any questions?
Is there like a ratio for BOD to new mass that's produced
There
as
is.
far?
I think that was that Jonathan.
Yeah.
I think you saw my slides. Um, all right. So Jonathan's question, he wants to know, can I figure out if I have this much BOD coming in, can I figure out how much VSS or TSS I'm going to produce? So this is a typical aeration basin. If we start on the left-hand side, the big yellow circles are our BOD, and the green circles are our bugs in the system. And so once it comes into the system, we obviously have BOD. So we have pounds of BOD coming into the system. And then as it goes through the basin, it gets consumed to the point where all of that BOD is gone. And we've converted that BOD into bugs. And so what we call this is yield or biosolids production. So when you hear people say yield, what's your yield of your system? What they want to know is how much TSS are you producing in your system? And the yield is typically based on your influent food. So our yield that we talk about typically is how much VSS do we produce? We consider our bugs VSS. Um, Basically, how many pounds of this do we produce per pound of BOD coming in? And so this gram you can change to pound, and I probably should. So this can be pound. It's gram per gram or pound per pound, whatever unit you want to use. Um, But Jonathan, the typical number is around 0.6, and you can calculate it for your own plant. So it's 0.6 for VSS. And then to figure out what the total TSS or mixed liquor is, you can take your typical MLVSS to MLSS ratio, which I put as 80% here or 0.8. I think each TRA plant might be a little different. Then I know Jonathan, you're on. So what's your MLVSS to MLSS ratio typically?
About 85.
Okay. What about 10 mile? Anybody at 10 mile know theirs?
Sure.
Cruise. Paul, do you guys know yours?
Like 79, 80%. I'm
Yeah,
looking at Wims now, yeah.
yeah, I think you're right, Paul. It's right around that 79 to 80%. So
You're right,
is
Claire.
there another plant on? I can't see the screen right now. I think the only one would be okay. Um, and Mike, for the 10 mile one, so you heard the differences between Denton Creek and Cruise. So Denton Creek had 85%, Cruise had 80%. Um, Paul and the Cruise people, what SRT are you at typically?
Yeah,
What was
like
that?
13 around usually.
I was gonna say Kerry's saying 13. I was gonna say 11, 12. So yeah, call it 11 to 13.
Okay, and then Jonathan, what's the typical
12.
what's the typical SRT at D Cruise?
6 to 8 days.
6 to 8 days. So one of the things in here that you'll notice is that with shorter SRT, you get a higher volatile fraction. Longer SRT typically means you're going to have a lower ratio. So Mike, at 10 mile, you have a higher SRT. I mean, so you're at the higher SRT, so you're likely going to be lower than cruise. Maybe you're in that 75% range, 80%. You might be 75 to 80%. At some point, it kind of bottoms out. You don't go any lower. But this is your MLVSS to MLSS ratio. And so we're going to go through a couple problems on this topic. So I hope some people have some paper with them. But we're going to take a typical plant. We're going to take an influent BOD of 220 milligrams per liter, an influent flow of 5 mgd, and then our MLVSS to MLSS ratio of 80%, or that 0.8. So how much TSS do we yield per day? So we want our answer in pounds per day. So I'm gonna let people, you get 3 minutes to think about it, and then we're gonna have a discussion about what's the first step. And you can start calculating it too, if you want to. The answer will be on the next slide. I will go back one and show you the ratio again. The ratios down here are 0.6 VSS to BOD and 0.8. So I'm going to put that ratio up here. So our yield we're going to consider our yield in this case 0.6 pounds GS per pound BOD. And that ratio, just as you guys are going through it, that yield ratio will change plant to plant. So not everybody's going to be 0.6. That's just a typical number. All right. Does anybody want to say what they think is the first step to solve this?
And calculate your pounds coming in.
All right. So how do we do that? So we have pounds. We want to calculate pounds in. What are we doing there?
I'm taking that 220 times your flow times that 8.34.
And Jonathan, can you explain what that 8.34 is?
Water, just a constant for water weight.
Yep. So that 8.34 is a number that you will see in a lot of equations we do, and it's just a conversion for us to get into convert into pounds. And it's really the weight of water. It's the weight of a gallon of water. Did anybody do the math on this? Anybody know what the pounds are? Besides Jonathan.
9174.
Is that what-
9,174.
Is that what everybody else got?
174.
Yes.
Yeah.
So you don't do the 0.6.
So that's how many pounds of BOD we have coming in, right? 9,174. Anybody disagree? So that's pounds of BOD per day. That's not our TSS yield yet, right? That's just our load coming in. So now how do we convert that pounds of BOD coming into the system into how many bugs is that producing? Like how many pounds of bugs is that producing?
You multiply by that 80%.
Do we multiply by the 80%? So if we multiplied by 80%, that would get us still pounds of BOD per day, right?
Yes.
And then how would we get it into VSS or TSS, Jonathan? Does anybody have a different next step? All right, so what we're gonna do is we're gonna take our pounds coming in, 9,174. And what I find helps me the most when I do this stuff is if you actually write it as a fraction, so that's pounds of BOD per day. And if I were to multiply it by 0.6 pounds of VS per pound of BOD, then when I do the math on that, my units cancel, right? My BOD cancels, and my units I end up with are pounds VS per day. Does that make sense to everybody?
But
Yes,
All right,
sir.
so you got 15,290.
15,290.
Yeah, oh wait, I divided by 0.6. Never mind.
I was gonna say, I don't think that's what I got.
5504.
that's what I got. And then I got 4403 at the end. I don't know. You gotta do something.
5504.
04.
Yeah.
All of that and then times
Now
0.6 gives you 5504.
Now,
I don't know all this
are we,
extra.
are we done?
It's the same. You just take all of that, multiply it, and you get the 5504. All of that times 0.6 gives you 5504. That's what I did originally.
Yeah. If you just do it all at once.
Divide it by the 0.8 gives you 4403 or times 0.8.
All right, so you took your 5504, you're dividing it by?
Times 0.8 is
So
4403.
how'd that get?
All of that is shorthand. None of that is curricular. You just take the first number 5 times 8.34 times 220 times 0.6 gives you 5504 times 0.8.
4403.
4403.
I don't know that he's right.
See?
So now we're gonna do this 5404. That's pounds of ES per day, but we want to know how much pounds of TS. And so we're gonna use our ratio. And I need VSS to cancel with the VSS in that ratio. It's a MLVSS. Oops, sorry. This should be MLVSS. Let me see if I can erase. right, so this should be MLVSS to MLSS. So now if I'm dividing by those, my VSS cancels out, and my units I end up with are MLSS or TSS, pounds per day. So Carrie was close, but not quite. What's your number now? I got one.
It's 6880.
Yep. So I'm gonna wait a minute. Does anybody have a question on how we got to this? And if we want to repeat it, we can. It's not something you guys have probably typically done, but I think it's something that you should be aware of, because then you can start to back calculate like what is your yield. So you could do this calculation in reverse to say I waste 6,880 pounds per day to my pounds of BOD. What is my ratio? And so I think it'd be good for most places, for most plants to kind of track this. And we're going to take this to the next step here in a few slides. But I want to pause to see if there's any questions on the equations or how we got to where we did. We will continue on. So how do we waste? So now that we've kind of done a little bit on what we produce, then how do we figure out, well, how much do we need to waste? So the wasting methods, one method is we can keep a constant mixed liquor. So waste to keep a constant mixed liquor. So we just every day we look at our mixed liquor, and if we're targeting 3,000 milligrams per liter, we try to get to 3,000 milligrams per liter. So all you're doing is just trying to keep your biomass in the system constant. So your biomass never changes. So if your system volume is always the same, that means you have the same pounds of biomass in the system. And if you have the same pounds of biomass in the system, it doesn't change if you have more load or less load. You're just keeping the same pounds in the system. So I would say, to my disdain, a lot of facilities still waste on mixed liquor. What we want to, by the end of today, make sure that you leave here knowing why you shouldn't waste by mixed liquor, and why you should look at other things. So the next one is F to M ratio. So we waste to keep a constant ratio of influent BOD to MLVSS. So that would mean that we're constantly looking at our BOD coming in, and we're comparing it to our MLVSS in the system, and we're trying to keep the same F to M ratio. The third way is our conventional SRT. So we waste to keep a constant average time that a particle is in the system. And so it's typically expressed as days, and that's what we're looking at. Is we're not trying to target like a biomass in the system, we're trying to target time in the system. And we know that within time in the system, we will have a certain amount of yield and a certain amount of waste associated with that. And it'll vary depending on load. So that way our biomass in the system varies depending on our load. So those are 3 different ways to do SRT. And in the last session, we talked about F to M and SRT. Those are the 2 main ones we talked about in the last slide, in the last training. So when we start looking at which ones of these, what is good and bad about these, if we start with the constant mixed liquor, it's something that you can kind of just look at your basic mixed liquor and basically calculate how much you need to waste down to, and monitor it at 3,000 milligrams per liter, for example. Why is this one good? Well, this one's good because it's pretty easy and it's quick. And you can kind of just know that you want to be around 3,000 milligrams per liter. The disadvantages of this is it really does offer the least amount of control over the process, and it doesn't consider growth. It doesn't consider changing load. So if your load increases and you keep your mixed liquor at if you keep your mixed liquor at the same thing, you're now running a shorter SRT. And so the disadvantage of this one is it doesn't consider changing conditions. So if you have more load or less load, you're not going to be holding a healthy biomass, which then can lead to excess decay, excess TSS out of the effluent. It can lead to poor settleability. Lots of factors that really get into this. A highly changing SRT will definitely impact like BioP performance. I think the only plant that has to make sure they monitor that right now is DCRUZ. But if you're constantly changing SRT going from 15 days to 6 days, I can tell you that your performance of BioP isn't going to be great. And if you're going from 15 to 6 days, your nitrification may end up having some suffer. Like if you go too fast, it may end up suffering as well. The second method is the F to M approach. And so this is where you're targeting that F to M. So you're looking at your influent BOD and you're trying to keep an F to M ratio. So you're trying to waste the system out based on your BOD coming in and your mixed liquor inventory in the system. So you'd be basically doing that calculation that we just did every day. Now, this definitely is a good approach. You know, it has load variability and impact associated with it. The biggest problem with it is that the BOD test takes 5 days. See, this one to run instantaneously would be a difficult one unless you were just guessing at what your BOD was each day, which you're probably going to be pretty close, but there's going to be days where you're off. And so that's why this one is one of those things that we use as fine tuning and that we look at on the bigger picture, a longer term, because we don't get BOD instantaneously. What we typically recommend you do is basically we're targeting time in the system with SRT. So we're going to target how many days we're going to be in the system, and then the mixed liquor is just a result based on load. We're not trying to control the mixed liquor. We're just targeting an SRT, and the mixed liquor is a result of what we're doing there. You basically get the most amount of control. It is a bit more abstract when you're thinking about like what does SRT mean? But just make sure you keep thinking about it. It's how much time is an average particle in the system. So if I grow a bug, how many days is he in that system? And so if we're running a 10-day SRT, that means that bug is in that aeration basin in that clarifier for 10 days on average. And this is something we don't need to rely on any BOD testing. We just need to rely on our TSS. So our RAS TSS and our actual mixed liquor, and then our waste volume. And so when we're doing the SRT measurement, you know, one thing we need to really make sure we're confident in is in our sampling and our measurement of mixed liquors, RAS TSS, our WAS volume. And then we're looking at this number, and then we can adjust it to get into a better F to M. And that's one thing we went over in the last slide deck in the previous session. Any questions on that?
So let's say we're getting hit with, you know, high random slugs of BOD. Would you recommend we control waste based on SRT? Would that be the best approach?
It would. So what's going to happen if we look at Jonathan, if you're getting hit with slugs of BOD, let's say that this is a really bad graph. Let's say this is time on the bottom. And we'll say this is BOD, oops, BOD, and we'll say this is MLSS. So Jonathan, if you were to go through time and your BOD did this, that's your BOD. Those are two slugs in there. if you were to hold the same SRT, so if you were to hold a 6-day SRT, what your SRT is going to do, it's going to take your mixed liquor and it's going to do something like this. So you will see your mixed liquor change with those slugs, depending how big the slug is and how long it lasts. You will see that slug come through in your mixed liquor concentration. Now, typically what you see, Jonathan, is that the reason the mixed liquor isn't quite as high is because you do end up wasting a bit more. Like your wasting is going to increase during those slugs to maintain the same SRT. Like your WAS volume will have to go up. So intuitively, you may think that you're changing your SRT, but you're not changing your SRT. You have to change your volume because you produce more bugs. Does that make sense?
Yes, sir.
Now, if we were to do the same concept and we were to just waste on mixed liquor, what would happen is our line would look just like this. Our mixed liquor line through all BOD loads. That means that if we maintained that, that means our SRT would do something like this. Our SRT would be coming along, it would drop, come back up, it would drop, it would come back up. And that's because you're wasting to a constant mixed liquor, meaning that if you have a slug load come in and you're maintaining mixed liquor and you waste more, you're actually running a shorter SRT. And that's where plants can really get into trouble. It may be that if you're a plant that hasn't grown or had a flow or BOD load change in 20 years, you can run constant mixed liquor because nothing has changed. But I would say that most, if not all, TRA plants, especially just Texas in general, if you go to another plant in Texas, there's a lot of growth in Texas. And so that's where you really need to be careful, and you can't really use that mixed liquor because as you're growing, you're increasing your load. And as you increase your load, your SRT is going to go down if you just keep holding the same mixed liquor. All right. This is our next set of problems. We're going to do calculation of sludge yield and basin loading. So same problem, right? These are the same things we had before. And we ended up with, we were yielding 6,880 pounds of TS per day. Pounds TS per day. So if we have an SRT of 10 days, this means a particle of TSS is in the basin for an average of 10 days. What is our mixed liquor? So if we look at scenario 1, so we have our yield, how many pounds of TSS are we producing a day? Our SRT of 10 days, and our basin volume of 1.53 million gallons. I'm going to let people think about how to get here. I shouldn't have shown you the answer. Let me go back now. So I'm going to wait 3 minutes again and kind of let you think about and run through some of these calculations. All right, who wants to take us through the first step?
So we took our six. What the heck did we do? Yeah, we took our 6,880. That's pounds of TSS and multiplied that by the 10-day sludge retention time. That gave us 68,800.
And that, what is that number? Can you guys explain that number to me?
What's that number is how many pounds per day per 10 days?
Yeah, if you looked at 10 days, that's how many pounds.
And that's pounds. What's another word you'd call that? Like if you were doing your
Yield?
no yield, not necessarily. I think you guys do this calculation and you call it something else. Like if you're a stock person at a grocery store and you're looking at your inventory. Yeah, there we go. That's your inventory in your system, right? I know this is Cruz talking. I think you look at your mass in your system, right? You look at your inventory. How many pounds are in the system, right?
Well, yeah, but
All
that's
right.
over 10 days. I mean, the 6880, that's like your unit cost. That's per day.
That's what this number is back here. Yeah.
Yes.
Yep. And this is how much will accumulate over 10 days if you hold it at steady state.
Yeah, because all you've done is multiplied it by the number of days.
Yep, correct. So now what's the next step?
So then we took our 1.53 million gallons. That's the volume of a basin. A small plant would only have one basin there. And we multiplied it by 8.34, which is, pounds in water. But that's right there in the formula too.
And
So
what'd
we
you
did
get?
that 12.76.
Wait, what 12.76? What's that?
1.53 times 8.34.
Ah,
The
gotcha.
bottom
So
number.
that
Your
was your
denominator.
12.76. Got
Yeah.
it.
Yeah.
So then we divided that 68,800 by the 12.76, and we got 5,392 pounds. And that's
Is that pounds anymore?
you're saying pounds to pounds cancel. So is that already milligrams per liter at that point?
Yep. That's what the 8.34 is doing that for you. It's converting it into milligrams per liter.
Sweet. And then, just kind of rough estimate, that's roughly 80%.
80% of,
The TSS.
oh, yes.
Yeah, that kind of let us know we were kind of in the right ballpark. Well, that and just doing the formula, but
5504, yeah, it would be 80%. So we're pretty close at 5392, which we're about 79% over here. So
Well, this wasn't supposed to be a cruise example. All right. Any questions on that?
that,
All right. I'm going to have you do one more. Scenario 2. So scenario 2 is the same problem, but now you've brought on another basin. So you looked at your system and you said, geez, 5,000 milligrams per liter mixed liquor seems pretty high. What happens if I bring another basin online? So I'm going to wait 3 minutes again. And just a heads up, Paul and Cruz can't answer this time. All right, who's taking this one?
You could pretty much cheat and just cut it in half.
You could pretty much cheat and cut it in half. So who has a I'm gonna walk through it then if we're not gonna get a volunteer. So we have our 6,880. That's our pounds we're yielding per day times our 10 days. We're still gonna get the same mass in our system, right? So we still have 68,800 pounds. So when you think about it, if we're running it, this is the point of running a 10-day SRT, is we're maintaining at this load. Remember, this is all related to that 220 and 5 MGD. At this load, our inventory in the system is going to stay the same at 10-day SRTs. And now, if we run into this system over here, now we're dividing that by, now we're using a double the volume. And so now we're getting, anybody have the answer?
2695.
Yep. So I guess I'll ask the question to people here. If you had the option to have another basin online, which mixed liquor would you rather run at? One of those is going to put less stress on your clarifier, right? You're going to be able to handle the clarifier is going to be less, like your clarifiers get solids limited, how many pounds you're putting in the clarifier. And if you're running at half the mixed liquor, that has a pretty big impact on your overall clarifier loading rates. I know that not everybody has the luxury of bringing on a basin. This is kind of just an example to show you. We could walk back through these examples, and I could have you guys do this at rather than 10-day SRT. What if I ran a 7-day SRT? What's that going to do to my mixed liquor? What's that going to do to your mixed liquor? We're not going to run it, but tell me what it's going to do to your inventory and mixed liquor.
Gonna drop it.
Going to drop it. And what's going to end up happening to your if you have a separate solids team? What are they gonna say?
You're
Send
gonna
us
be
more
way.
sludge.
Yeah, go ahead.
Yeah. Go ahead, Jonathan.
You said what is the dewatering department going to say, or what
Yeah,
do you?
yep,
What's your?
yeah. What's the dewatering department gonna say?
Oh, send us more sludge.
Yeah, they're gonna look at it as, oh, why are we getting more sludge? It's just the nature of you managing the liquid stream. And so that's just one thing that it's allowing you to get more capacity on your liquid side. Assuming that you can operate at that SRT, you're gonna get more capacity because you're gonna have lower mixed liquor. All right. So any
Real quick
questions on
though,
these?
yeah, then I say something real quick. So if you're talking about, if you had a lower inventory and less strain in your clarifier, the double-edged sword of that, as far as we talked about with being in Texas and unpredicted loading. So if you had a massive slug come in and you get low solids inventory, you're risking not enough inventory to take care of the junk coming in, right? So it's kind of a potential catch-22 where you're at.
That's the biggest thing, and that's kind of when we talked about Carl, like the last meeting was typically we recommend having like a 2 safety factor on things. And that way you have that usually provides you enough safety factor in your system. But that's a good point. If you start lowering your SRT too far, you're going to run yourself into a risky situation. And that's why the next section I think is actually how do we determine minimum SRTs. But yeah, you don't want to trim your mixed liquor just to trim your mixed liquor. If you can operate your system at a 10-day SRT and you get good settleability, and it's a safety factor of 3 or 4 or 5, and your clarifier is okay and you can handle peak flows, then by all means, that's a comfortable spot to be in. Not everybody has that luxury. Any questions on what Carl was bringing up there?
Oh, who?
So I think it's Carl at 10 Mile or Mountain Creek. So
Come on,
yeah,
Carl, you
we've
gotta
had
know
the
where he's
thing.
at.
We've had the thing before too, where it's like, yeah, we could run a lower mixed liquor, and because that's whether you say we're running off mixed liquor or not, we're lower in the mixed liquor, doing it this way. So we can say, yeah, we'll run a lower mixed liquor, and that will be less of our clarifier taken up with solids. So we've got more room in the clarifier, and provided the sludge is settling correctly, we can push more flow through the clarifier, which is good. Because if you don't waste right, the clarifier will do it for you. And we can send more to solids. We can send the higher flow rate to solids because they can now handle more because it's a lower volume of solids for solids to deal with. But we need that buffer because who knows? I mean, you've been here a long time. Who knows what we're going to get sent? We get sent something toxic and we're running a skeleton crew of bugs. We're going to get wiped out.
Yeah, I'm not like so my message wasn't to cut SRT or anything, Paul. I want everybody to know the different levers and controls they have within their systems. And you have to balance all of that with knowing like your safety factors, and why you operate the way you do. I thought Paul was going to get to FTMs. Well, that's what I was hoping you were going to get to, Paul, at Cruise. So Cruise operates this 10 to 13 day SRT, which, that's a safety factor of, I think we calculated it last time. In the summer, that safety factor is probably in let's say 12 days, 1.5, you're probably in the eight safety factor. It's a healthy safety factor. But one of the reasons they run at that safety factor is a lot of this F to M ratio. And if they start to really decrease the SRT, their
Yeah.
F to M goes up. And what
Yeah,
happens
well,
when your F to M gets too high?
Yeah, when we talk about having the inventory to handle a toxic load situation, that's exactly the F to M. I'm looking at my food, what's coming in, because we were just looking at our BOD over the past month of October, and I mean it looks like a roller coaster. So that's our food on a roller coaster. So we have to have microorganisms to handle that.
Yep. And that goes back to this. I think that goes back to this, and it may be hard for everybody to see what that is anymore. And that's where you're managing that. I mean, you guys do manage it. I know, Paul, you said that you're managing mixed liquor, but you're really managing SRT. You're running your SRT calcs. Your mixed liquor does change a bit in the background. I mean, you guys aren't always at 5,500. It ranges from 53 to 57 sometimes. You know what I mean? There's still fluctuation in there. And that's when you're running at that constant SRT, you'll see that mixed liquor change slightly with the higher load coming into the system. And I can tell you that I think, Daniel, are you still on the phone? He might not have a mic. I know that in the last call last week, it was mentioned that the Cruise liquids was increasing their wasting. And a lot of that might be due to what you're talking about, Paul, is that roller coaster, right? You're getting higher slugs of BOD. You're getting some slugs of BOD or higher BOD loadings, and you end up having to, in the long run, you're increasing wasting to maintain the same SRT. Let's see here. So to wrap up, why should we be using SRT? You're going to get a higher quality effluent. That's one of the biggest thing that I can say is your higher quality effluent is going to really be Like an optimized SRT with a good F to M is going to have better settling and less junk in the system. So when you start running like an old or a young sludge, either one, an old or a young sludge, you'll start to see what we call less capture in the clarifiers. So when you go into your clarifier, you want flocculation, right? You want all your TSS particles to kind of sweep out any of the smaller particles, so you get good high quality effluent TSS. And what we start to notice at higher and lower SRTs, or higher and older sludges or younger sludges, we don't get as good a capture of TSS. Our settling properties aren't quite as good. And so that's one of the main drivers in optimizing that SRT. You get just better quality effluent. You need the microbes. I mean, that's what you guys are all here for. That's your main part of your job, is maintaining the microbes. And they grow at a certain rate. And obviously you want to not remove them faster than they can grow. Any questions on that? This is kind of the last slide, so any questions? Hear any? Let me look for any chat.
There's none in the chat.
Okay. Well, let everybody get going. Like we mentioned, we will release slides and a recording of this. We'll get those links out after this week, so don't expect